Alright, now let's talk about how we can evaluate trig functions if we're not given an angle. So that sounds kind of weird, but you'll see in the next example, it's when it says like the sine of an angle equals a ratio. Alright, you're pretty much just going to draw a picture. So use the given information to draw theta and make sure it's in the right quadrant. They'll either tell you the right quadrant or enough information to find the right quadrant, or sometimes you don't have enough information to figure out the quadrant and there could be multiple answers. So we'll look at that. Find any missing sides using the Pythagorean Theorem. Identify which sides are x, y, and r, and then plug the values in to the definitions on the previous slide. Not sure if those are on the previous slide, but definitely a slide before this one. Find all 6 trig functions of theta given the cosecant of theta is negative 8 over 6, and theta is in quadrant 3. Alright, so that's nice. They told us the quadrant, so that's one less thing we have to look at. We'll talk about what do we do when we're not given the quadrant later. So here's theta. Okay, it's going to look something like that. Now, if the cosecant of theta is negative 8 over 6, what I'm going to do is immediately say that the sine of theta is negative 6 over 8. Okay, so that's opposite over hypotenuse. So if we look at theta hat, alright, this entire thing is theta. That's the angle in question. And we're going to use the reference angle, theta hat, which would just be, that's theta hat, it's just this part here. Okay, since this is sine, we know that that's opposite over hypotenuse, or if we use our new definitions, y over r. So now if I plug a point in right here, alright, this point is going to have a y coordinate of negative 6, and it's going to be 8 units away from the origin. Okay, so if we draw a right triangle here, this opposite leg here is negative 6, the hypotenuse is 8, and now we have to do the Pythagorean Theorem to figure out what x is. Okay, so now when you're doing the Pythagorean Theorem, make sure that you square with parentheses. So negative 6 squared is going to be 36, not negative 36. If you type it in on the calculator like this, you will get negative 36, which is why you want to use parentheses. Alright, and then I'm just going to finish solving. Okay, so I got x is equal to the square root of 28, which I'm going to factor by doing 28 is 2 times 14. 14 is 2 times 7. So the square root of 4 is 2, but the square root of 7 can't be simplified, so that stays inside the radical. Alright, and since this is in quadrant 3, that x-coordinate is going to be negative, because it's really this point down here that we're finding. Alright, so we're going to go from the origin, we move to the left 2 root 7, and then down negative 6. So using our new definitions of trig, x would be negative 2 root 7, y would be negative 6, and r would be 8. And now I'm just going to plug those into our formulas. So cosine is x over r, so that's going to be negative 2 root 7 over 8, which you could simplify to just negative root 7 over 4, which would make the secant of theta equal to 4 over root 7, negative of course, which rationalized would be 4 root 7 over 7, and that's negative 4 root 7 over 7. Tangent would be opposite over adjacent, so it's negative 6 over negative 2 root 7, which is just 6 over 2 root 7, positive, which becomes 3 over root 7, which would simplify to 3 root 7 over 7. Alright, and then when you flip that, you get root 7 over 3 for cotangent. Okay, in math, in algebra, you probably learned about inverses. Inverse means to switch the domain and range. So if you're given an angle and you wanted to find the sine of the angle, you would plug that angle into sine and get a ratio. But let's say that you didn't know the angle, like in this case, and you wanted to know, well, what angle would you take the tangent of to get 1? Well, you would use the inverse and then plug the ratio into the inverse and get the angle. Alright, so let's find the tangent of x. So let's find x given the tangent of x is equal to 1. Now, if you had this table memorized, then you could say it's 45 degrees or pi over 4. But there's actually more than one answer, and let's look at why. And let's use the calculator and see what the calculator says first. Okay, so now I have a T9 Spire opened. I'm in degree mode, so I'm going to do trig tan inverse of 1, and I get 45. So that makes sense, because the tan of 45 is equal to 1. Now, there's actually another answer that works, and that answer would be the tangent of, well, if you know it, pause it and think about it for a second, but if you want to see the answer, that would also be the tangent of 225. Now, why are there two answers that work, but why does the tangent inverse of 1 only give us one answer? Well, that has to do with functions, something that you learned in algebra. So a function is when you have an input, like you plug 45 into tan, and you get an output, you get 1. So that's like your domain, and that's your range. So if you plug in 225, you also get 1. Now the inverse of that function is when you switch the domain and range. Now if you remember, this wouldn't be a function if you plugged 1 into the inverse here, and it gave you more than one answer. All right, there can't be two y values with one x value. So the calculator, when you do the tangent inverse, and tangent inverse is defined as all the angles between 90 degrees and negative 90. All right, cosine and sine work that way as well, and I'll get more into that later. But you have to understand, when you do tangent inverse or sine inverse or cosine inverse, it's only going to give you the angle in quadrant 1, or for tangent or in sine, the angle in quadrant 2, and for cosine, the angle in quadrant 4. So it's always good when you do inverse to take the tan inverse of the positive ratio, and you'll always get the reference angle. Then, once you know the reference angle, you could find the angles using what you know about the quadrants. So if all trig functions are positive in quadrant 1, then 45 degrees would be a value of x that works here, because we're trying to get positive 1. But really, any angle in a positive tangent quadrant, which would be quadrants 1 and 3, right? 2 and 4 are negative tangent quadrants. So positive tangent quadrants that have reference angles of 45, so the other angle would be 135, okay? That would be another answer that works. And there's really an infinite amount of angles that you could plug in here to get 1, but since it's only between 0 and 360, we're only going to use those two.